And anybody who comes in after this will just have to catch up by looking at the beginning of the recording. Good. If you thought that I had finished with triggers on Tuesday, you were sadly mistaken. I'm sorry to inform you. Let's just move on. The triggered programs within the database are, in my honest opinion, the most significant component for giving your database intelligence, agility, self-awareness, and also saving hundreds of thousands of lines of RPG code and stabilizing your data, securing your data. Therefore, I do spend a lot of time on a trigger program. And based on a couple of questions that I got, I'm going to have a look at those questions. Then we are going to look at the mini or micro database that I have in place and look at some real things that you can do with triggers and the code that you can do them with. So to begin with, this is the simple diagram of trigger programs where the PAG contains the file definition tables, and RDBMS uses that in order to call trigger programs for and on behalf of a particular table. As I have illustrated or explained before, trigger programs are in no way interested at all in who did the calling. If you want to know that in your trigger program, then you have to arrange to know that in your trigger program. I will be, probably over the weekend or before next week's session anyway, I will be attaching sample code for different types of trigger programs to the meeting, which can then be downloaded from the meeting. And you can begin to use those as templates, and I'll take you through those today. So this is generally a simple view of what the relationship is between the program, the database management system, the table, and the trigger. The trigger communicates with the database management system and tells the database management system what RDBMS needs to do as a result of the call. That means if the trigger program sends an escape message to RDBMS, it's an abort. If the trigger program doesn't send an escape message back to RDBMS, then it's a tacit approval to continue. We'll have a look at that, and we'll have a look how that communication takes place. But let's move on to a couple of the questions that I got. And this one was actually quite relevant, surprisingly enough. I love triggers. I do everything in triggers, but if within a file, and I'm going to pick a file, here is the little mini database in AO. I hope it's big enough for all of you to see. If we have a look at something like the address file, which we have got here, and we look at its number of columns, we can actually see that the customer number does not need to be validated because there is a relationship between that and the customer master file. So no validation is required for that particular field. The address type, let us assume that it's a 5-character and there are half a dozen different types of addresses. That's a fixed validation. And let's assume address types A, B, C, D, and E, for example. That needs a validation. Nothing else in this table can actually be validated. The record status is blank. It's not used by this file. The address lines, address line 1 must contain something is probably the best validation you can do there. And the postcode must contain something. You could, of course, use validation, exotic validation on the postal code by having a postal code table and looking it up and seeing whether it matches the address line, etc., etc. But we're going to keep it just a little simple for the purposes of illustration. So I have basically 2 types of validation that are required for this file. The address type needs to be A, B, C, or D, or E only, nothing else. And address line 1 needs to be non-blank. Now, under those circumstances, a check constraint can be written that would do the job. You could say check where address type like A, B, C, D, E, and address line not equal to blank. And that's all the validation that that particular file needs. The constraint validates the customer number and nothing else is validated. In that case, you can put that validation for this file into a check constraint. However, a check constraint is limited. Its scope is only the file to which it is attached. It cannot reference other files and other data environments. It can't do fancy calculations without a lot of complex work, and it can only work on fields that are within a single table and cannot cross over tables. I will show you some validations later on where it's obvious that you could not do this with a check constraint. So what I then do is I say, okay, if I don't need a trigger program because the validations are simplistic, I can use a check constraint. But I am pretty sure, in fact, I'm almost 100%, I'm putting money on it, that in every single one of the databases of people listening to me now, there are files that will have upwards of 30 fields in them, of which probably 20 to 25 are going to need some form of validation. That makes very complex check constraints. And in fact, some of them you may not be able to do with check constraints. You might have to be forced to use a before trigger. Now, as soon as that happens, my philosophy says quite categorically, I do not want my validations in 2 places. I.e., I do not want part of the validation for a particular file in a check constraint and another part of the validation for that same file in a trigger. Because that's messy, it's difficult to manage, and it's difficult to know where to look when you want to look it up. So, in the case where a file only needs a check constraint, you can use a check constraint. Where you need a trigger, you use a trigger. And if that file also could do with check constraints, you put those tests into a trigger. So that what you're faced with here is you're faced with either a trigger or check constraints, but never both, because that's complicated. That is why I tend to look at triggers, because I find that, well, sorry, let me back up a bit there. Right, so the idea is I don't want validations for one file split over 2 places. So I have triggers, and then I have check constraints. But then I realized triggers are so easy. They're so simple. They're so fast. Why not rather do all my database business rule application and validation using triggers and not do any check constraints. Because then I only have one place to look, one repository of business rules, and that's in the set of trigger programs, one for each file in my database. So I only have to have one place to look. I don't have to worry where is it in the check constraint, is it in a trigger, is it in both, where am I? So although the check constraints are very easy, and sometimes they're very useful to put a temporary restriction on, which you then want to take off again later, because that then saves you having to compile the trigger program twice. Once to put it on, the other to take it off. So check constraints are useful in that respect. But I rather prefer the flexibility of triggers, and you'll see what I mean just now. And I would rather have all my validations in one place, so that I can look at trigger number, at the trigger CUSADRF, that's the file name, underbar B something, B0. And in that trigger program are all my business rules and validations for that file. They're all in one place. I can find them quickly and easily, and I can add to them or modify them in one place with one compilation. And I don't have to worry about the possibility of things in somewhere else. That is why I tend to restrict each file in my database to one before trigger only. I'm going to just open the triggers here on this view, and you will see that the customer master file in my mini little database has trigger called cust_fbd. That's for before delete, cust_fbi for before insert, and cust_fbu for before update. The program is exactly the same. It's called B0. So it's the same program that is attached to 3 events on that file. And so I know that all my validations for that file are in that one program there. And that is the reason, or the answer to the question as to why I prefer triggers over check constraints. Because they are more flexible, and I've got everything in one place easily identifiable. Okay, if there are any further questions on that, put them on a piece of paper and send it to me. I have no problem. Let's have a look at the next one. Applying the techniques of modernization via constraints and or trigger programs. This is written as is up on the slide as it was written. I'm going to suggest that for correctness, we scratch out the and or and just make it and, because every file in a normalized DB2 relational database will be constraints and triggers. It's very rare that you will find a file without at least one before trigger and without at least one constraint. Moving the validation of data to the database. Okay, so applying the techniques of modernization and moving the validation of the data to the database. That means pulling it out of the programs and applying it to the database in the form of triggers and constraints. This does not safeguard our data if we fail to code for the validation of any field. Absolutely true. If you fail to put a validation into a trigger, then whatever client you're using can put anything into that field. that it feels it wants to. So the art here is to define your business rules and validations in the triggers as completely as possible. There are some files, some fields, like an address line. You can't validate it, except to say it must not be blank. And of course, and I'm sure you will all laugh at this, because you all have users who discover that they can't put in a blank, but if they put in a full stop, they can get away with it. So I normally validate for blank and point in the first position, and that baffles them until they get smart and put 2 points. You have no idea how determined users are to defeat the rules wherever possible. And that is why you can upgrade your trigger programs. You can upgrade the strength and the level of your validation when you have a nice separated trigger that doesn't impact your application at all. You can enhance that validation until you are satisfied that your data is safe and you can sleep at night. Okay. This is a question which looks very similar to the previous one, but isn't. Populating columns in a table. Your application program or client populates a record and writes it to the table. That is intercepted and passed to the trigger first. And the trigger can, if you allow it to, and I stress that, you have control of this, the trigger can change the contents of fields, which will override a column before that column gets applied to the actual table. So the trigger program can do that. It can insert a user ID, it can insert a date timestamp, it can prevent something from being changed. It can make sure that if you've left it as a blank, it actually gets a default value put in it. It can make sure that if you've written zeros into a null capable field, the trigger can force that field into a null state, where your application program may not have done so. So there's many things the trigger can do to control what eventually gets written to the file. Now I'm talking here about before triggers. An after trigger doesn't have that benefit, because an after trigger like this one here is after the record has actually been written into the file, and therefore you cannot change its content. Now I'm going to use this to just show you how you control the behavior. This, by the way, is AO. It's not the native interface. The native interface would be add pftrg. That is the native interface. There is an equivalent statement in SQL, which I would recommend you don't use. And here you specify the physical file and library to which you are attaching the trigger. You specify the trigger name and event, and which program is going to be used by the event when triggered. So the first set of information is pretty straightforward. The replace trigger option is simply to say, if I have a trigger of the same name on the file at the present time, do you want me to replace it, yes or no? It's a fairly straightforward thing. If you say no, and there's a trigger with the same name as you specify in this column, then it will say, sorry, I can't add this trigger because there's one already there. Now, the name of the trigger with a star gen option is similar to the name of the constraint with a star gen option. The system generates, to my mind, an unnecessarily long and wobbly name for you. My trigger conventions, name conventions, which we're going to look at the constraint name conventions, my trigger name conventions are very simple. File name, whoop, where am I? It's file name. So my trigger name convention would be file name underbar, either an A or a B, depending on whether it is a before or an after, followed by an I, a D, a U, or an R, depending on whether it's insert, delete, update, or read. So insert, and then 2 numerics, or 1 numeric, actually, because I've never had more than 9 different triggers associated with the same event. So that is the trigger name. Then you get one of these a very strange thing here. It says trigger library. Now, just focus. A trigger is a definition that is built into the file definition so that it can be accessed by RDBMS through the file definition table in the PAG. However, the trigger definition is actually seen as a separate object and can be stored in a library, i.e., the trigger definition is associated with a library. It's the same as the constraint definition is also associated with a library. It appears, if you use your iNavigator, it appears as a separate object and can be in a separate library. Now, it's probably the worst thing you can do to change this default here. This default, which says star file, means store the trigger definition in the same schema as the file itself. If you don't do that, it becomes nasty to find trigger definitions, and you can begin to lose them and have double definitions, and I really don't ever let it happen. And in fact, this, which is the native command, this particular parameter doesn't appear in the AO command that does the same job. I leave it out. By default, I always put the trigger definitions in the same library as the file. Right. This one is cute. The wording, believe me, is nasty because it doesn't say what it really means. Allow repeated change. This is the parameter that you add to the trigger definition to allow multiple changes to take place, i.e., you're allowing a change from the client and a change from the trigger itself. This is the allow repeated change parameter. I will press F1. Specifies whether repeated changes to a record within a trigger or any subsequent triggers called while the trigger program is running are allowed. I.e., what it's saying, and this is where the word, the description of it to me doesn't suit, is the trigger allowed to change the contents of a record? But notice the subtle thing here. Within a trigger or any subsequent triggers. Because do remember something. You can get, and now, of course, I'm going to start your mind going around in circles. If I have a program which is changed by a client, that calls a trigger. If that trigger then requires to make changes to another file, that might call another trigger, which may make changes to another file, which will call another trigger. And what you're getting is you're getting a cascade effect. And if you specify on the first trigger that the allow repeated change is yes, that applies to all subsequent triggers called from that particular trigger. Even if the subsequent triggers are not allowed in their own right to allow repeated change. Now, if I didn't confuse you with that one, I'm not doing my job. If you say no, and this brings us back to the question, if you say no in that particular parameter, then the triggered program cannot override the value of any column from the client. I.e., if I say no, which, by the way, is the default, are not allowed, and therefore you cannot change the contents of a column from within a trigger. This parameter, by the way, is ignored for after triggers. It's only applicable to before triggers, because you cannot change a contents of a column with an after trigger. The default in the client or in the native command is no. When you look at it in the AO command, we will look at this one. You will see I've actually changed the default so that the default in the AO environment is a yes, because I have found often, in fact, more often than not, that having that facility available in the trigger is of great benefit. Okay, you notice there's some other things missing here as well. Let's just look at the native command again. So that is the repeated change command. Only applicable to before triggers and only if it's yes is the trigger allowed to alter the contents of a record. Moving down, thread safe and multi-threaded job action. I have never used them. I've had a look at them. It doesn't seem to be, unless I'm getting very exotic, worth getting involved in this sort of thing. So I don't worry too much about that. If anybody knows anything about it or would like to do the research, I'm more than happy to distribute it amongst the group. The next one that we use is trigger update condition. The trigger update condition, always or change. This controls when the database management system calls the trigger. If the trigger update condition is always, and this applies only to the before and after insert trigger, it's ignored for all other triggers. But if it says always, DBMS will call the trigger for every update, regardless of whether the record was changed or not. Now, I can't really understand why somebody would want to update a record without changing anything. But if you use the always condition, the trigger will always be called even if the contents of the record remain unchanged. There are possible reasons why you would do that. I find that, in fact, the change option is the better one. It's obviously more performance efficient because it will only, when set that way to start change, the trigger will only be called for an update if there is a difference between the before image and the after image, i.e., if somebody has made a change to the record, the trigger will be called. If the two records are identical, the trigger will not be called. So if we look at this you will see, because this is an update, we now have the update condition, which showing is change. We have the allow repeat, which is showing as yes, because this is a before trigger. And the state is by default enable. You can change a trigger state, you can disable a trigger, and you can re-enable it. Now, obviously, a disabled trigger is not working. It is attached, but it is disabled, and therefore it is not performing the function for which it was designed. And it's as bad as removing the trigger link altogether. So it's almost without any conditions whatsoever that a trigger must always be attached and in its enabled state. However, there are some times when one is working with the database, and particularly if you are maybe doing, I don't know, a copy, making a duplicate of a file, and the file that's going to receive all the records has also got the same trigger attached. Maybe you do want to disable that trigger for the data copy because it's already on the file, already valid. You do not need to call the trigger every time you copy a record across to the new file. So you can disable the trigger during the copy, but you must remember to enable it afterwards. Okay. There is an after trigger on this file as well, and you will notice that it's an after insert. So neither of those two allow repeated change, or the other one, call trigger when, neither of those are there because it's an insert. So AO is simply making it easy for you to fill in the right ones. So what we have here is, you can see the update trigger is changed, is called only on change. And the after trigger, this yes is by default there. I don't know why it keeps coming up. That's a small bug that's been around for a long time, but the operating system ignores it anyway in the case of an after trigger. This is the yes, which says allow repeated change, yes or no, and it actually shouldn't be there for the after trigger because it's not allowed. Okay, so in the case of this, that customer master file has 4 triggers. One after an insert, and one program that is attached to the before delete, before insert, and before update events. So let us have a look. We will look. I just want to make sure I've answered all the questions. I think so. Let me just get back to that. Right. This was just a naming convention for my constraints, which came up from last session. A primary constraint is table table name with a P, a unique constraint table name underbar U with an N, 0 to 9, check constraint C, 0 to 9, and a referential constraint table name underbar R to 9. These are names that are given to you by AO. Oh. They're given to you by AO as defaults. If you want to, for example, add a trigger to this address file, you would simply open the context menu and click trigger, and you would then be allowed to add a trigger definition to that particular address file. And you can see it suggests and fills in the names and so on and so forth, and the defaults and everything else. You can change these names. You can change your program names to whatever you want to. Not a problem, not a big issue. However, the conventions that I use have worked for me for many years. They're simple, they're short, and they're quite descriptive. So that's entirely up to you, to whether you use the naming conventions or not. Okay. Where am I now? Here I am here. Just a quick refresher before we move on to something a lot more exciting. You have the before insert, delete, and update with a maximum of 300 triggers in total. On per table, you have after insert, delete, update, and read, and of course the instead of, which we will not talk about at this stage. So you have 7 events, 3 before, 4 after, and you can attach multiple programs to each event, or you can attach the same program to multiple events. And my norm is to attach one program to the 3 before events and one program to the after events if I need all of them. Very often in the case of after, you may not need all of them, although if you're collecting audit data, then you will definitely need a program that is attached to insert, delete, and update in order to collect audit records for the activity on the table. Okay, just to emphasize again, I keep throwing this thing out. I fixed it so it doesn't have all of it. We have a physical database, DDS to DDL, and we're now talking about the triggers. The triggers are what give the database its autonomy. And that I keep stressing this, and I hammer this, and I go on and on and on about this, because all my validations are written in triggers. I don't write validations in application code anymore at all. Right. This is what our little database is beginning to look like. We have certain files, tables, in a fairly logical arrangement that I'm pretty certain you can all relate to. It's not going to worry you too much. You can see that the green arrows are relationships. On the circle, there's a many. If there's an arrow, it's a 1. So it's 1 to many here, 1 to 1 here, 1 to many addresses here, and so on and so forth. So these relationships that are built into the database create the first level of integrity checking in the database. You are checking that a file exists in the customer master file before you can create an invoice header. And an invoice header has to exist before you can actually create details for that invoice, etc., etc., etc. You will notice I've put before and after triggers. I've left it out here because I didn't have any space. I've left it out of these two because I got lazy. But at the very least, one should examine your file carefully. And I will take you through a little routine of what I do with a file when I'm building a trigger. So this is the diagram that we're beginning to move towards by now adding triggers. And I'm going to utilize, this is the database, and we are looking at the current triggers that are added to this little database. There's the master file. It's got its triggers. It's those two triggers there. The before and the after. I haven't put triggers on the others. We will do so shortly. Now, the question is a before trigger on the customer master file. What does it do? Now I have to go and find there it is there. Right. Here is the code. I hope it's big enough for everybody to read because there's nothing much I can do about that. This is the actual trigger code that I wrote in order to support this particular little database that we are looking at. And it was chosen very specifically because this trigger is a trigger for the customer master file, CUSMSTF. But it also requires an FSpec for another file, the balances file, because this trigger works not only with the customer master file and its validations, but it also works with the balance file in certain circumstances. So it has an FSpec that it can now utilize another file. That's why it was particularly chosen as this example. Here is your prototype and your parameter interface. There is your parameter list, which is like this one, which we discussed on Tuesday. We talked about the basic parameters up here, and then we talked about the set of parameters indicating old or original record and its various offsets and lengths, and the new record, offset, length, and so on of the null byte map. Here is the original record pointer, the original record, new record pointer, new record, and defined as we saw it on Tuesday, no variation. This trigger is a trigger that is designed to work on a file where the client application can handle trigger errors. The one I showed you on Tuesday was a special variation of it, and I believe Marina sent you the links to the article that explains how that works. Adding triggers or pulling the trigger without shooting yourself in the foot is the article which shows you how to do a completely risk-free add of trigger programs to legacy or heritage files and application code. Right. Triggers communicate with the database management system using messages. And therefore, you have to have facilities for handling messages. And what I have done over the years is I have mimicked the way that the operating system percolates messages. I have created a service program and service procedures that do all the definitions and the shifting backwards and forwards and everything. And so I've minimized the impact on my application code to the degree that they've now sort of stabilized into a basic set of error handlers that do everything I want them to do. The first one, which is error 03 and the most commonly used, it moves diagnostic messages that have been received by this program and resends any escape messages. Now that is basically move the diagnostics and then resend an escape message, the escape message that arrived in this program. So this program actually doesn't need to know what went wrong. This is a trigger program. Something went wrong somewhere. There was an error, and I just want to bring the outline. I want to catch the outline mode here, because the outline of a program tells me if I'm looking for prototypes, error 03, you can see it is used in a lot of different places. I can find out exactly where it's used, or I can go back to its definition, which is there. This is used as an automatic percolation device. Any diagnostic messages that have arrived in the call stack message queue will be moved into the database management system. Now, this is important. Understand that the caller of the trigger is not your program. It never was, and it never will be. The caller of a trigger is your database management system. So error messages are sent to your database management system because they go one level up the call stack, which is into your RDBMS. This one moves all diagnostic messages that the trigger received and then sends the escape message that it received. Now remember what I said, when a trigger sends the database management system an escape message, the management system recognizes that as an abort and will roll back any changes that have occurred and will return an IO error to the client program. It will move all the diagnostic and escape messages from the trigger to the client and create its own IO error message at the back, which simply says, the trigger chucked you out. And if you've done your diagnostic messages correctly, the reason why that particular action has happened is available in the client's message queue or in the client's job log. So it can be seen there or actually programmatically accessed there and passed on to the user. That's 03, move diagnostics and resend escape messages. 10 is to send a diagnostic, i.e. from this trigger program to send a diagnostic to RDBMS. That's the message ID. That's what message file it's defined in. That's the replacement data, and that's the message target. I put the message target into my error handlers so that I could actually send it more than one step up the call stack. I could send it to a program boundary or a control boundary. I put it in right at the very beginning when I was young and naive. I have never used it, but it's still available in the code. This one here is send an escape message. Same thing, message ID, message file, message data, and message target. Now, I'm not sure whether you're aware that when an RPG program sends an escape message to anybody, it is an explicit return as well. i.e. the moment an escape message is sent from an RPG program, that RPG program terminates and passes control to its caller in the stack. So sending an escape message is equivalent to a return with error, and the database management system recognizes it as such. So here is the three error handlers that you need in a trigger. Now, obviously, you can write these your own way. But save you the trouble, I've actually created the code, and I will make it available to you. Well, it is available. If you look on our website, it's in the outsource section. The error handlers are all there. And you're more than welcome to download them and use them. Word of warning, though. If you download and use any code, it's under a, what license did I put it under? An MIT license. And it's provided as is and without warranty. And please be sure that you make it your own and understand what it's doing before you embed it into your production system, because that could not be a good thing. Okay, I then have a few procedures we'll get to later. I have an error indicator which I use to control whether an error has occurred or not. And in this particular case, I have a user ID. And the reason for that is that this file, which we're going to validate, which is the customer master file, I have a user ID at the bottom, which is going to be the user ID. I think I defined it as the user ID of the last person to change this record. That needs to be maintained and managed. So let's have a look at what the trigger actually does. Remember, this trigger will be called on an insert, a delete, and an update event. It's attached to all three events, and a record is passed to it that contains a before image and or an after image, depending on the type of event. And the main line in a trigger is usually no longer than that. All it does is it decides which event has occurred and what it's got to do with the event. It establishes the base parameter pointer and then sets the new record pointer if it's an insert, the old record pointer if it's a delete, and both if it's an update. And depending on that, it will go to the default routine, the insert event routine, and the validate routine, as you see there, or the update event. Now, let's have a look at those procedures or routines. They are procedures. Now, I wish I could do this all in one lump, but it's very difficult. Later on, we will talk about procedures, sub-procedures, sub-functions, service programs, and all that sort of stuff. But specifically here within a trigger, this is what we would call a sub-procedure, i.e. it is a procedure within a program used only by that program, and they are defined after the main line of code. The procedure can be seen as a mini program in its own right. It has file definitions. It can have data definitions. It can certainly have calculation routines. And it behaves exactly like a program. It occupies another level in the call stack. So it adds to the call stack level. So in every sense, a procedure, which is what you're looking at here, from the P to the P. In every sense, the procedure is a mini program. The only thing is you can't call it directly. It has to be called using a procedure call, which looks like that. This could be preceded by call P, but if you've been using Freeform RPG long enough, you will know that call P is optional as long as you've got the double brackets at the end. That then recognizes a procedure call and you don't need the call P in front of it. So the default is call both on the insert and on the update. And it's to make sure that the defaults are correct. Remember, this trigger is attached it's the before update trigger. Was it the before update trigger that I was looking at? Yeah, well, it's the before update. It is called on changed, and it does allow repeated change. And that's what I need if I'm going to provide defaults. Now, at this present time in the life of this program and this evolution of this application, the record status field that was put in for future use, it's a habit of mine, I've done it for years, hundreds of years. It's put in there for future use to control and indicate the status of the record. In this particular file, at this particular moment, it is not being used. So I put in a default and force it to be a blank. The reason for doing that is to make absolutely sure that if it's an unused field, I don't want it to collect an assorted variation of 1 or 2 byte characters at random from clients that don't actually know what it's used for, and so they will accidentally put just about anything else into it. I want to make sure that it stays blank until it's used for something specific, at which point I will validate it to make sure it conforms to the specific rules. So that is a default. The other default is to take the current user, logged on user, and put that logged on user into the user ID. Now, I can tell you, because I've been there, that when you start using triggers and you start doing things like slotting the user ID in, or slotting the change time date stamp in, or putting a star none in place of a blank, somebody is going to come to you and say, there's something really weird going on in my program. Every time I try and put this person's name in the user ID, it changes it to my name. And I don't want my name there, I want this person's name. And I can't understand why the program is not doing it. And that's because it's being overridden by the trigger. I've been there. I've had people who've made manual changes through SQL to a file, and they have wanted to hide the their user ID by putting somebody else's name in there. It's actually happened. That's not pie-in-the-sky problems. So the trigger makes sure that the file carries the name of the user that actually made the change. And it carries exactly the right time, and so on and so forth. So defaults may or may not be needed, but one has to examine the file in each case. Now, in this particular case, there's a certain action that needs to be performed when there's an insert occurs. There's an action for the insert that does not and must not be done any other time, i.e. it mustn't be done on an update and it mustn't be done on a delete. And that is to actually put today's date into the customer start date, i.e. when was that customer record actually first inserted into the file. Now, the trigger does that in this simple a manner. Once you've coded that one line of code under the insert event procedure, you never ever have to worry about there being any doubt that the start date on the customer record was the date on which that record was inserted into the file. And it goes along with the update event that makes sure it never changes by always taking the old start date and putting it into the new start date. So the update event together with the insert event, those two lines of code, only two lines of code guarantee that this file's start date will never be any other date other than the date on which that record hit the file. Can't happen. And in fact, I think that's is it a date or a timestamp? No, it's just a date. It's not a timestamp, but it's a date. You could just as easily make it a timestamp if you wanted to. And this is where triggers begin to start coming into their own. Two lines of code. And I can guarantee you that that field on that file will never be wrong. Never. Can't be. And you can't override that with a SQL client. You can't override it with DView. You can't override it with anything. Because the trigger's not interested in where the request is coming from. It's only interested in what is in the file. Okay. Now, so we have an insert event, which does that. And we have an update event, which does that. We also specifically have a delete event, and this is another reason that this particular setup was created, was to show you all three of the specific event actions in action. Remember, we have a customer balances file, which we created to contain the balances for that customer. We separated it from the master file because it was the volatile portion of the database, and you will see it contains the customer number, a record status again, the current due, 30 days, 60 days, and the customer total outstanding. Okay, please remember that I'm sure you've got files like this and that are a lot longer and a lot bigger and a lot more complex. But I did not want to overexpose the situation with too much clutter. So that is the reason for that. Now, this delete event is in the before trigger. It's specifically, hi Chris, it's specifically in the before trigger because if you are attempting to delete a customer, what is the one thing you want to be absolutely certain of before you allow a customer to be deleted? You want to be absolutely certain that that customer does not owe you any money, because otherwise you will lose the record of that money that customer owes you. So this is how it's done. I use the old customer record because remember, this is a delete event. So I only have an original or old customer. I don't have a new customer. So I use that old customer to chain to the customer balances file. And you will see just now why I know there is a customer balances file. I'm not even bothering to check that because I know it's there. And if the customer total outstanding is greater than 0, I will turn on an error and I will send a diagnostic message. which says, let me see if I can find it. By the way, those message numbers also have some meaning, because no, I can't find it. It says something to the effect that you're attempting to delete a customer which still has balances or still has a non-zero current balance or something like that, and the error indicator is turned on there in order to stop it happening. Because we will go back up here, and after getting to this point, if the error indicator is on, we will issue an escape message. That is an escape message. And that escape message goes back to the database management system, and the database management system passes all these messages as it's collected onto the client, and then aborts the update, or the delete in this case. It will abort the delete and tell the user that you can't delete this because their balance is outstanding. Now, if you look at the number of lines of code I've written here in this trigger, and you start counting mentally the number of lines of code you would have scattered all over your application to make sure that you didn't accidentally delete a customer that had balances, you can be sure that this is the only place you need to make that test. And again, no client of any type can bypass it on condition of two conditions. First, the trigger must be attached, and secondly, the trigger must be enabled. If the trigger is attached and enabled, nobody can delete a customer that has outstanding balances. One of AO's main functions is the background cross-check, which makes sure that nobody is fiddling with the definitions on the database under the covers, so to speak. I'll show you that a little bit in the future. Right. Here we come to the validate routine, which is applied in the case of the insert or the update. So, the validate routine. You reset the error indicator. You then test if the customer number is 0, track out an error. Now, this is the customer master file. And depending on how you assign your customer numbers, you don't want it to be a 0. It's not a good thing to have a 0 customer. If you are assigning customer numbers automatically, then this particular error is this particular test is probably never going to fail. It'll only ever be invoked once on a brand new empty customer master file. And people will turn around and often say to me, well, why bother? Because there's a 999,000% chance that putting triggers onto my existing files, I will never have to test this. True. Without a question of doubt, it's true. Unfortunately, I'm OCD. And that, to my mind, if I've identified a customer number being 0 as an error, it goes into the validation trigger regardless, because it is an error. It might never occur, but it is then documented as one of the business rules quite clearly that the customer number may never be 0. That's a business rule. If it's found to be 0, the error indicator is turned on, and a diagnostic message is percolated into the database management system, explaining what the problem is. This one is testing the customer's name. If the customer's name is blank, there's an error. I don't want a blank customer name. As I said, there are some business validation rules that you cannot get away from. I can test for not blank, but if the user is really saying, I don't know what his name is, I'll find out later and update it, and they leave it blank and they get it chucked back at them, they will then put in a full stop and the application will accept it and they will forget to come back and fix it. We've all been there, you know I'm talking the truth. So I could also test in here for a full stop, or a double full stop, or a question mark. But eventually, the user's going to beat me, which is the reason why, in most cases, why is this? I don't know. Oh, of course. I've got it on the other screen, sorry. Which is why, under a lot of circumstances, I will actually do this and put a user ID in the file. That means if I come across a customer name that's got a full stop in it, I actually know who was responsible for doing it. And I can track them down. Okay. So, obviously, this validate routine is small. If you look at the customer master file, now, and this is the rule. This is in answer to one of the earlier questions about what happens if you leave out a validation. The trick here is not to leave out a validation, and the way you do it is quite simple. And by the way, let me just give you a little preview. The next development project on the AO development list is to create a trigger program generator, which will also build in rules validations predefined for each field. So we are moving in that direction to make it even easier to create a trigger program that will include and encompass the proper validations. And there are always, one must remember, there are always two levels of validation for every data element. One is the validation level that relates to the business, i.e., customer number or customer name must be a decent, proper name. There are, in some cases, not all cases, there are different validations or additional validations that depend on which file that field is in. There are two levels of validation. Definitely business rules for the element, but then there may be additional rules for the element in a particular file. And the intention with the next development is to create a way of defining those at both levels and having AO generate a trigger which incorporates all of them. The way you do it in the meantime until you have that toy is you go to the list of fields in file and you look at the first one, you highlight the first one. And you say to yourself, right, what validation does this need? Now, this is a customer master file. Therefore, this customer number is being created within this file. Do I generate it? Do I allow a naught or not allow a naught? Do I want it to go up in tens? Whatever you look at it, because it's the customer master file and it's where that customer actually originates, that number originates. You look at how you want to be sure that it gets a valid number. Now, the most common way of doing this is to assign a sequential number. As you go, each new customer gets a new number. But your business may have complex customer numbers that integrate a whole lot of elements. Area, state, I don't know. You have to look at that customer number and you have to say, how do I validate it? Because this is the file that I need to validate it on. Because of referential constraints, I never have to validate it again. Because every other file in my database has a referential constraint from customer number to this file. So I validate it here, I never have to validate it anywhere else. Everywhere else, it's validated by referential constraint. Look at the record status. That's the next one down. Oh, this file's not using it. Therefore, I can put it into the trigger as a blank default. Customer name. Well, you've seen my validation of customer name. Other than that, some fields very little. Start date. Well, I've solved that by never having to need anybody to input it. I'm creating it automatically in the trigger. I'm making sure that it can never be changed. I don't need to validate it. Phone number. Telephone number. Is there any way of validating a telephone number? And you look at it, and this is why AO actually lays it out like this, because you can look at it and you can say, what validation do I need on that thing? Now, at the very best, you can ask for a non-blank phone number. At the worst, you may want to validate area code and make sure that it's the right phone. You can go as complex as you like. But you have to look at that field, not in the context of the file so much. As in, what does business want? Does business really want a valid phone number for every customer? If they do, then you must validate it to make sure there's one there. That's the important thing. You then move down another one and you look at the next field, which is rep code. And the question here is, what do I validate on rep code? And the answer to that is I don't. I don't need to validate rep code. Why? Because I have a rep master file. And I have a constraint between the customer master file and the rep master file. So that constraint means that no rep code can be entered into this field that doesn't exist in the rep code master file. i.e., the rep code is a foreign key to another file. Therefore, it does not need to be validated because the constraint is doing the validation. Now, as with everything in this business, there are always exceptions. But you deal with those exceptions each time the exception occurs. For example, an exception in this case, maybe there could be an area code for a rep. Reps maybe have certain assigned areas. And some way you want to ensure that this customer is within the rep's area. That's a variation on validation. It's a business rule. And if that is a requirement, it must be dealt with in the trigger, by the trigger, and nowhere else. the trigger might need to go to the address file. It might need to look up the postal code. Maybe your reps have been assigned postal code areas, and it then needs to check to see that the in fact in the postal code that is assigned to that rep. As I say, there are so many permutations and combinations out there for different systems, it's impossible for me to give you examples of each and every one of them. As I've often said, I'm more than happy to help you come to a solution if you can give me the facts. But you first of all got to look individually at each field in the file, and you've got to make a decision as to whether you need to validate it or not. And if you need to validate it, write that validation into the trigger. Because that's the only time you will ever have to do it. And if you do it right, you will never ever have to test it again. You will never get a bug out of it. You will always have the right data in your database. And you will have plenty of time to do new things and good things rather than chasing around and fixing errors all over the place. Switch down to the last one here. Do I need to validate the user ID? The answer to that is a resounding no. Because this trigger is creating the user ID. Therefore, I don't need to validate it because I don't need to validate what doesn't exist, or what I am creating myself, rather. So, in fact, out of that record, only two fields, the customer number and the customer name, require to be in the validate routine. And actually, even the customer number is debatable, depending on how you assign your customer numbers. So you can see that there are more comment lines, or what I call, these little red lines are my thought lines. There are more comments in this program than is actually executable code. In fact, the executable code is minimal. And yet, it guarantees a certain behavior for that file that cannot be broken. Right, now I'm going to switch to the other trigger because this file also has an after trigger on it, and it has an after trigger for a very special purpose. The after trigger is only attached, if I can find it now. The after trigger is only attached, as you can see here, to the after insert event. It's not attached to the after update, and it's not attached to the after delete. It's attached to the after insert because I only need action after a record is inserted on the customer master file. An after trigger has a slightly different structure because it has no validation. I've got my little select clause there with insert, delete, and update. I think I do this just because I cut and paste more often than I don't. But also it means I can add code to this and attach it to another event without having to change this particular little routine. But it's rather immaterial. Insert, I set the new record pointer, and I go to the insert event. And the insert event does one thing and one thing only. It sets up the customer balance record and writes the customer balances record to the file, i.e., the after trigger writes a blank customer balance record to the file every time a customer is inserted. So there can never be any doubt. I'll explain this right just now. There can never be any doubt as I said to you earlier when I came to the before trigger with this default, the delete, I can chain to the balances file. I don't even have to test to see whether there's a balance record there, because I have created one when the record was inserted. So I know there's one there. I can never delete that balance record if it hasn't got a zero balance, because of that control. And it doesn't matter what client I'm using, the same applies. And always bear in mind when you're working with triggers, it's only a one record per cycle program. One record at a time. You're not dealing with multiple records. You don't have to have any fancy coding for multiple records, because it's only dealing with one record at a time. And that, by the way, includes SQL. If SQL inserts a record, updates a record, or deletes a record, it's deleting the whole record or inserting the whole record. And therefore, the same RPG trigger written in exactly the same way caters for the requirements of any SQL activity on that file as well. How the SQL activity handles the error messages that are returned by the trigger is a problem for the SQL client. Okay. I have got two other triggers written as part of the example, and these are attached to the invoice detail file, which is here. Oops, I've done it again. Which way am I supposed to be going there? They are the before and after triggers attached to the invoice detail file. And the action is as follows, and I'll go through these as well, because this is a slightly different view of a trigger process. You'll notice, by the way, I could throw examples of trigger programs at you for the next 3 months. Strangely enough, they all look essentially the same, but depending on the file, they behave slightly differently. I'm just going to open the invoice detail record. So I've got it at my fingertips. This one has a customer number, an invoice number, and a line number. You can see it's got a three-level key, three-component key. It has a record status, product code, item quantity, product price, and line total. Obviously, on a proper one, there would be a few more bits and pieces of information, like discounts, etc., etc. But the important thing here is what the trigger does with it. Before insert, before update, before, I haven't even created the before delete. And the reason I haven't done that is because this constraint here is a cascade delete, i.e., if the header is deleted, all detail lines will be deleted as well. So I don't need to attach a trigger to the delete event. In fact, what is important to understand is I can't delete a trigger. I can't attach a trigger to a delete event if there is a cascade delete constraint in place. It's one restriction. I still haven't 100% worked out why. I would imagine that it's seen as a particularly dangerous exercise to have a cascade delete with a delete trigger, a delete event trigger before or after it, and that it could actually run away and demolish your entire database without you knowing about it. I don't know. But that is a restriction, that if you have a constraint that has a cascade delete, you cannot have delete event triggers attached to it. Sometimes that becomes a bit of a nuisance, I have to admit. But what can I say? Let's have a look at what this before trigger does. In the event of an insert, I go and look at the defaults. And the defaults make the record status blank. Again, the record status is not being used in this file yet, and therefore I make sure that it's blank. I have commented out the insert event because there's no insert event, but there's a validate. And the validate is very simple. It validates just the item quantity, and it says the item quantity must not be 0. And in this case, that's a valid validation. Because what's the point of putting a line on an invoice that has a quantity of 0? So definitely, if your client does that, you want to initiate an error, which of course does exactly the same thing, error on and a diagnostic message to explain what the problem was. But after we've done the validations, there's another step for both the insert and the update, and that is a routine called calculate. Calculate says if the error indicator is on, i.e., if it was turned on for any reason during the validation process, I don't want to do the calculate. So I return immediately. I don't bother to execute the calculate routine. In the calculate routine, you'll notice in this particular trigger, I've got a product master file is defined in an FSpec. I chain to using the product code from the record to the master file. I multiply the item quantity by the product price and come up to the line total. And then I insert the product price into the new product price on the invoice line. So this is the calculation of the line total that does not need to be done by the client program because it's done in the trigger. The fields are there. The client can fill them in if it feels like it, but they will be overwritten by the calculation that came in the trigger. So here is an example of a business calculation that is done by the trigger. For example, you could expand this even further. You might have a procedure or a subroutine or something that calculates discounts on, these fields are not in this record, but it could be used to calculate discounts based on quantity and customer. Certain customers over certain quantities get certain discounts. You could then call another procedure in the same calculate routine that will then take the result of all of that discounted value and add a tax, a value-added tax, federal tax, state tax, whatever you like. That could be a completely separate routine. but it could be called from this calculate routine inside this trigger to apply those values to this record, so that all of that calculation for the invoice detail file or for any other file that you deem necessary is done, managed, controlled from within the trigger, written once, tested once, and never looked at again. And now I think you can begin to see why triggers, to me, are the be-all and end-all of a very, very intelligent database. They can do a lot. They can be a lot with very few lines of code. They can solve a lot of the problems that we have with big monolithic programs, some of which have one validation, some of which haven't got quite the same validation. The classic one, of course, is a tax, calculated tax, which in one case is rounded up and the other case is truncated, so the tax never actually matches, and all sorts of things go wrong in that environment. That's the first one that comes to mind. Rounding is a big problem with calculations. So calculate in one place and one place only, and then you don't have that problem anymore. Let's just have a look, because there is an after trigger on the detail record. Let me see what it does. You'll notice that this has an input-output server. There's a customer balances file there. And if you look at the insert event, this is an after trigger. So remember, an after trigger has calculated and it's validated, and the record has now been placed in the file. It's not yet committed, but it's placed in the file. Okay, everybody can see Ed's question. Yes, Ed, the answer is you can use an I/O server. In fact, as you can see in the after trigger, I have used an I/O server, but I put the F-spec in because it's more familiar. Once I have dealt with the topic of the I/O servers, and you understand what an I/O server can do for you, then no I/O should occur with an F-spec. They should all be done with I/O servers. Hope that answers the question. Right, so if you look at the insert event, chain, using the customer number and the invoice number, which is in the detail record, I chain to the header file. Here, I read the customer balances file. This is an input-output server action. It's right next door to a chain. It does exactly the same thing. It reads a record with that key out of that file, but I put them next to each other so that you can actually see those are two identical statements. They both chain or read the same, one record from the header file and one record from the customer balances file. Now, because this is an insert, I take my invoice total. By the way, it's prefixed by an I, because the I is, the header record is prefixed by an I. So I add the line total to the invoice total. I also add the line total to the total customer outstanding, and I also add the line total to the current. I update the invoice header record, and the same way as above, I update the customer balances record. So what this after trigger is doing is it's maintaining both the invoice header file, the totals on the invoice header file, and the totals on the customer balances file. In the case of a delete, I do exactly the same thing, except I minus equal the line total from the invoice total. And I remove the line total from the balances, and I update the two balances. Piece tacky. Easy peasy, as they say. Then, when the update event's slightly more complicated, I chain to the two records. I then increment the invoice total by the difference between the new and the old line total, i.e. between the difference between what it was and what it is. And I always have to look at these calculations very carefully to make sure my signs are right, and I believe they are. But if you think they're wrong, please feel free to yell at me. I do exactly the same on the customer outstandings to adjust those totals according to the update event, and then I go and update the two. That's it. I actually could put those two lines of code and those two lines of code up here. And only have the calculations down in these event routines. That's a personal choice. It depends how many lines of code you actually want to write. My personal philosophy is that I don't care how many lines of code I write. My concern is the number of lines of code that get executed through each pass of a trigger. And here comes the warning. When a client presses the enter key, there is a possibility, if your trigger is not carefully set up, if you overdo it, if you go completely overboard in terms of doing 17,000 levels of processing and going crazy, your user may have to wait some time before that transaction is completed. The trigger is additional lines of code that need to be executed that are not obvious. They do not appear in the application program. They are in addition to, and they are yet unseen. They are hidden. So although they are very, very optimized and they run at priority 0 in the machine pool, so they are exceptionally highly optimized, you have to be careful about not overloading a trigger to the extent that it begins to impact on the user's response times. Now, here's an interesting discussion, and maybe you can write to me about it sometime. A trigger programs, even complex trigger programs, when attached to files that are being interactively updated by a user through a keyboard, can actually, if one thinks about the relationship between human response times and human reaction times, i.e. how long it takes you to find the enter key and actually press it, in comparison to the speed with which the modern IBM I processors can actually get through code lines. Quite frankly, from the computer's perspective, a human being sitting at a keyboard is hardly moving at all. And so the 1 or 2 nanoseconds, milliseconds, or even fractions of a second that it takes for the trigger programs to complete a complex series of events is actually neither here nor there when you relate it to a user sitting at a keyboard. In fact, the user probably won't even notice it in most cases. However, I know there are a lot of heritage or legacy systems out there that run massive overnight batch jobs. And that is where the extra few microseconds that it takes to complete each individual transaction when running in batch mode over 100 million records can begin to show serious problems. And you've got to bear this in mind when you are designing your triggers, and you have to know that that file is being updated by a batch program, and you need to know the volume of records and how long it takes and when it's run and all the other things that revolve around batch processes. Because from a trigger's perspective, a user at a keyboard may appear to be traveling very slowly. From the trigger's perspective of a batch program is that it's running just as fast as the trigger. Therefore, the impact is much higher. And you can take a batch job which, let's assume in a legacy environment, runs for 4 hours at night. You can extend its runtime significantly, up to 6 hours, just by adding triggers. Now, I hear you all thinking, yeah, but if I'm running batch jobs, I can do all of this in the batch job, and then that means that what I can do is I can disable the triggers while I'm running the batch job, and I can enable them again afterwards. Now, if I could speak in capital letters, I would say in caps, don't even think about it. When a trigger is designed and written and attached to a file, the only thing you have to be interested in caps again, the trigger remains attached to the file at all times, under all circumstances, in all environments. That means development, test, and production. Because if you don't do that, you cannot control what is happening. Better, if you have a batch program problem, is to consider the possibility of getting rid of the batch program by doing the processing that the batch program is supposed to be doing, using triggers 1 record at a time. So instead of your batch process going from 4 hours to 6 hours, it goes from 4 hours to no hours. And that is the modern paradigm when it comes to batch processing. Going along with that, day-in batch processing can be handled by before and after triggers. by adding a millisecond or so to each transaction throughout the day. You don't have to do a day-end batch process at all. By adding dates and times to every record in your database, you can get away with weekend procedures and month-end and year-end procedures. You don't need them. All you need is data extracted and reports produced. You don't need to do any actual processing at day end, weekend, month end, or year end. So your periods are then set up just to produce the necessary reporting, which we know these days is not even necessarily on paper. It can go to Excel spreadsheets or whatever it is. The blessing about doing it that way is that should you lose a month-end file because the dog ate it or I dropped it in the toilet, you can simply repeat it because it's date-based. And the dates are in the files. So you don't have to do complex recovery procedures. You just simply have to run it again with the right date parameters. So this is this type of thinking you begin to consider when you start talking about trigger programs. Because trigger programs can do an awful lot that batch programs do. And you can get rid of your batch. Then your nighttime processing, it becomes available for producing reports or all sorts of things, and you eliminate the stress zone, which has got to be finished by 5 o'clock in the morning because the heavy usage starts to come up. Or in a lot of cases, if you're running 24/7 shops, then the load that batch processing puts on the system overnight disappears, and your performance remains consistent day and night. So the power behind a trigger before and after triggers is enormous, unbelievably huge. If you approach it correctly, and remember that it is a learning curve, and yes, you're going to have to modify programs in order to accommodate trigger behavior. For example, this whole business of calculating the balances on the header file, that lot, probably, if you had this type of environment, would probably be found in, I don't know, half a dozen or more programs around your production environment. They would all be doing exactly the same thing. You need to find it, and you need to eliminate that, and you need to replace it with triggers. It's not something that to be taken lightly, but you've got to believe me. I insist that you believe me when I say that doing this properly can remove all your batch processing. It can remove 80% of your lines of production code. And of course, that means reduce your testing time by 80%. Improve your accuracy because you only have one thing written in one place and not spread all over the joint. Consistency, etc., etc. That's created by the constraints on the database, on a normalized database. The constraints make it fully relational, and then you add the triggers to apply your business validations at the database level so that it can take over. You can put a lot of activity into the database engine where the heavy lifting can be done. And believe me, that leaves your applications to handle two things: to display information to the user, to collect data and information from the user, and to tell the user what the result of that database interaction was, i.e., did they get it right, did they get it wrong, what they need to fill in, what they don't need to fill in. So your processing becomes an interface between the database and your front end, whatever that might be. I am going to collect these examples, and I am going to try and bundle them. I might put them into a zip file or a source file or something in the Dropbox, or I might just attach them to the meeting agenda. You know, I can attach files to the meeting. And if I attach a file to the Webex meeting, you will get notification that the meeting has been changed and you can go and download the files from there. I've just got to see what the most convenient way is for me to do it. But I will get you examples of these things before our next session, all being well. Okay, please, mails with questions, very much appreciated. And I think that just about finishes off triggers, unless you have plenty questions, in which case I please beg you to put them onto a mail and send them to me so we can cover them. All right. Thank you very much for listening to me. I do appreciate you. And have a great day. See you on Tuesday.